Okay, so today I'm just going to add an inline regulator to reduce my battery voltage from 7.4 volts down to, I believe this one's 5 volts, just in an attempt to extend the life of my servos a little bit. So I'm just going to show you how I would go about doing that. So here we've got our regulator. I'm not sure how sensitive these are to static, so I'm just being careful to touch the edges and not touch any contacts if I can avoid it. So you can see on the left here we've got 2S to 4S. I'm using a 2S battery, so that's fine. And this will be our output. And if we look on the underside, 5 volts there, which hopefully will be enough to drive these servos. So it's a fairly straightforward process. Normally I would tin these wires beforehand, wherein you melt some solder into the wires. But because these holes are quite small in this PCB, I'm going to try and do it without tinning first. So hopefully that will work okay. So if we just feed these through initially. Bit fiddly, there we are. I'm just going to bend that so it stays in place. We can lay that down there. Okay. It's worth noting when soldering you want some pretty good ventilation, just because the fumes are not good for you. It contains lead, so you want to be careful to not inhale any of that if possible. So I like to just snip off maybe 15 centimeters of solder at a time, so it's just easy to manage in your hand. You don't have to worry about coiling it up or anything. It's just nice and easy to work with. And then if we apply a little bit of heat to the pad, and then just apply a bit of solder in there, we should be able to get that to drop off nicely into the hole in the PCB. And there we are. So that should be a reasonably strong solder joint. And if we look at that, that looks okay. We've got nice contact there. So I believe we're all right. Just get that to focus. There we go. So that's filled in that hole there. And then we'll do the same with the negative lead off the battery. We'll just fold that over at a similar angle. Lay that back down. So that looks good positioning wise, and then we will just do the same again where we apply a bit of heat to the lead and feed a little bit of solder in there. Have a look at that connection. Okay, so we've got no bridges between the positive and negative there, and they both look fairly well attached to the board, so I think that will do. I'm just going to take a moment now to trim the wires off, the excess leads here. So you can just do that with a pair of small sort of snips or pliers. There we are, that's that one. There we go, so that's trimmed nice and tidy there. So I'm just going to take the opportunity now to slip a heat shrink sleeve over the whole assembly. Just because once we attach the other end it becomes a lot more difficult, as we'll have to negotiate the plugs. Hopefully we've got one big enough to fit over here, I believe so. So that looks like a good size, the whole thing fits inside there. So once we've soldered our other side on, we can heat shrink that down, and that will protect the whole thing, and then we can just treat it as a sealed unit and we shouldn't have to touch it ever again really. So here's the side that attaches into my receiver. So this is just a servo plug where I've taken out the signal lead and we're just using the positive and negative. So we'll separate those apart and we'll just strip maybe 1 centimetre on each end. It's nice to have pliers that have this sort of notch, which makes it a little bit easier. You can also buy purpose-made wire strippers, which do make this even easier because you don't have to worry about the correct tension on the wire. You just stick it in, squeeze it, and it will do the job. There we are. So we've got those nicely stripped. We'll just twist those up so we don't get any fraying issues when we feed it into the board. So I'm just twisting that. We'll just twist that. Okay, and then we'll find our terminals. Okay, let's twist those a little more. So then same again, we'll just apply a small blob of solder. There we are, that looks good. Looks like our negative could do a little bit more there. There we go. So if we take a closer look at that, they look fairly well attached. So again, we'll just snip those off. Nice and easy. Make sure we've got no bridges between the two contacts, so they look good. And then if we put our heat shrink sleeve over there, like so, and then if we grab a lighter, and there we are. So let's just confirm that that works. So we get our battery, plug that into one end. take our there we are. You can see that our receiver started flashing, so we didn't break anything in the process there. And there we go. So that's all reassembled now. The electronics are kind of in temporary locations, so I probably won't keep the battery sitting where it is. And at some point I will shorten the servo leads to kind of tidy everything up. But it seems to be working quite well. One thing I have noticed is that it definitely moves slower now. But that kind of makes sense because the RPM of a motor is generally proportional to the voltage supplied to it. So having gone from 7.4 or maybe even 8.4 down to 5, it makes sense that it'd be a bit slower, but it still seems to have plenty of torque, and hopefully it'll be a little bit more reliable now, and I won't have to change servos every 20 minutes or so. So call this one a success.